We will learn about the diesel cycle now. Diesel cycle is also known as constant pressure cycle, as the constant pressure heat addition is shown here from process 2 to 3. 0 to 1 is the suction process. In the suction process, air is taken inside the engine cylinder. As this is the diesel engine, only air is taken inside the cylinder. 1 to 2 is the compression process, where the air is compressed up to pressure P2, and process 1 to 2 is the adiabatic compression process. 2 to 3 is the constant pressure heat addition process. 3 to 4 is the adiabatic expansion process. 4 to 1 is constant volume heat rejection. Here volume V1 is equal to V4. Now the difference between Otto and diesel cycle is mainly observed here, where the heat addition process is constant volume in case of Otto cycle, but in case of diesel cycle it is constant volume heat addition process. Rest of the process are similar. What are the different assumptions of diesel cycle? We will see. So the working fluid substance is air, it is assumed. Now air behaves like an ideal or perfect gas, and its specific heats are constant and do not vary with temperature. Suction is happening from 0 to 1 and exhaust also happening from 1 to 0. Both the process are shown on the same line. Now these are the assumptions and these all are the theoretical condition, ideal conditions. Heat addition takes place at 2 to 3, heat rejection at 4 to 1, but ideally it is not possible. Even the valve open and close exactly at TDC and BDC respectively. All the four stroke takes place during 180-degree crank rotation. All the effects like friction, viscosity are neglected in the ideal diesel cycle. Now, some very important aspects of diesel cycle we'll see that during the heat addition at constant pressure, air expands from volume V2 to V3 and the fuel injection actually starts at V2 and cut off at V3. Okay, so in actual engine, heat addition takes place in the form of injection of fuel, which self-ignites due to high temperature caused by high compression ratio and burns at constant pressure as piston moves down. The volume ratio V3 upon V2 is called cutoff ratio and is denoted by symbol ρ. Compression ratio and expansion ratio are not equal in diesel cycle. Air standard efficiency of diesel engine. So efficiency is work done upon heat supplied, where work done is nothing but heat supplied minus heat rejected. So heat is supplied from 2 to 3 and heat is rejected from 4 to 1. So constant pressure heat addition Qs is equal to mCp T3 minus T2, whereas constant volume heat rejection is equal to Qr is equal to mCv T4 minus T1. Now we'll see the dual cycle. In case of dual cycle, 1 to 2 process is the adiabatic compression process. 0 to 1 is naturally the suction process, then the compression process. 2 to 3 is the heat addition at constant volume, and 3 to 4 is the heat addition at constant pressure. 4 to 5 is the adiabatic expansion process, and 5 to 1 is heat rejection at constant volume. Here we may observe that heat addition process is combined. 2 to 3 is constant volume heat addition and 3 to 4 is constant pressure heat addition. So the thermal efficiency, it is heat supplied minus heat rejected upon heat supplied. Heat supplied QS is calculated by combining these two, MCV T3 minus T2. So for constant volume process, MCV T3 minus T2 plus MCP T4 minus T3. So this is heat addition. Heat rejected at constant volume. So MCV T5 minus T1. So when calculating efficiency, if you add all the values in the equation, finally we will get efficiency of a dual cycle is equal to 1 minus T5 upon T1 upon T3 minus T2 plus gamma into T4 by T1. We'll see what this gamma term is. So in case of Otto cycle, it is 1 efficiency 1 minus 1 upon gamma raised to R raised to gamma minus 1. So R is the compression ratio. In case of diesel cycle, we may observe the equation. In case of fuel cycle, we may observe the equation.